Hello guys, welcome back to Maths Zone African Motives, still on our revision on the Kirchhoff's laws for Industrial Electronics N3. We are going to focus on this question paper, August 2015, whereby we are being given to use the Kirchhoff's method to determine the current flowing through the 5-ohm resistor. So we've got the 5-ohm resistor in this fig 1 that we have here, that is 10 marks for everything. All right, so let us try and see. This time you are not given like the loop to consider. You're just given your diagram like this. So you are the one who is to consider your own loops to use. So just choose the loop that is not complicated for you, because it's your choice, this one that you are going to make, unless you are given a loop to take. But in terms of the currents, we are already given here, because of the positive terminal that we have and the negative, gonna see our current flow in this way, where we have got our current 1, which branches at point B to current 2 and current 3. So as we can see, we've got 3 unknown values, I1, I2, and I3, which is I3 is this part that we are supposed to calculate. So we are supposed to calculate the current that is going to flow through the 5-ohm resistor, which is we are supposed to determine the current I3 in this case. But as you can see, if we use I3 into our equation, it means we are going to be working with the 3 unknown values. So let us avoid that, working with I1, working with I2, and also working with I3. That means we've got 3 unknown values. So you're going to write this I3 in terms of I1 and I2. So what is going to be the expression of I3 in terms of I1 and I2? So you're going to have this in terms of I1 and I2, so that we avoid having 3 unknown values. So as you can see, due to our Kirchhoff's current law, the current I1, which is the current flowing towards the junction, should be equal to the sum of the currents flowing away from the junction, whereby we are referring to current 2 and also current 3. So current 2 plus current 3. So we can make current 3 the subject, transpose I2 to the other side. That is going to be current 1 minus current 2 is equal to current 3. So that is in place of current 3, we are going to write this as current 1 minus current 2 in this case. All right, sometimes they do calculate this for you. They just write here current 1 minus current 2, then you wonder where it is actually coming from. So that is, we are just have to make the subject from there. So we have got I3 in terms of I1 and I2. Now it's going to be easier for us as we consider our loops in this case. All right, so the first loop that you're going to just take, like I said, this one is a question of your choice. You play it around the way that you want. So as for me, I'm going to consider my first loop from this voltage source of 8 volts, and I don't want to work with the negative. So the direction must be from the positive. I'm going to take it from the positive in this way, so that I avoid working with negative. So this is going to be my loop 1. In this case, all right, for this loop, I can even consider this way. This one does not affect because I do not have a voltage source. So the direction does not matter. But here, if I take it this way, if I take this loop this way, it means the voltage is going to be affected as a negative, because you are opposing it, the direction of current. So it's going to be a negative. But if you take it this way, your voltage is going to be a positive in that case. All right, so let us consider my loop 1. According to my diagram, my loop 1. So you can even consider your loop 2, even the whole of this part, like the external part of your circuit, can be your loop 2. Guys, it's up to you. This one is in your hands. All right, just work it the way that you want, as long this part is involved in that loop. If you take this, 5 ohm is involved. If you take this side, 5 is also involved. As long that value is involved in the loop that you have taken, it means you can work. I mean, as long everything that you have, like your equations are fine. You might not have this in your equation, but as long like you take the right direction, that's what I'm trying to explain. Sorry for that explanation that I just put into through there. Is as long we are having direct equations, exact equations to be followed. All right, so loop one, I'm just going to take this as A, B, and so on. So I'm just going to move from A to B to E to F, then back to the point A. So it means this here I've got a voltage source, and this will be taken as a positive as I'm moving from the positive in this direction. So I'm maintaining the direction of the flow of current. So that's the voltage source 8 there is equal to the sum of the voltage drops. So which voltage drops we have in this loop of AB? The current flowing there is I1, and we've got a resistance. If we take this from E to F back to B like this, we have got a current I1, which is the same current flowing there. And we are maintaining the direction of the current, so it's going to be positive. And the resistance there is 6 ohms, so it's going to be 6 times I1. So we've got a current and resistance there. We move to the loop, which consists of I3 in this case, which is from B to E, going this direction, all right? So from B to E, as we can see, going this direction, we are maintaining the direction of the flow of current that was indicated here. We are moving this way, we are maintaining the direction of flow of current, so that is going to be a positive as well, all right? Then we've got a resistance there of 5 times the current, which is current I3. So our current was supposed to be written as I3 like this. But remember that I3 is the one that we wrote here in terms of I1 minus I2. So this is going to be given as I1 minus I2 like that. All right. So if you want to write I3, then you substitute from there, it's fine. But just know that this whole part here, it represents what? I3. Okay, so that's it. Let us expand brackets so that we can collect our like terms. 5 times I1, which is going to be positive 5I1, 5 times negative I2, which is going to be negative 5I2. Then we can collect our like terms here. We've got 6I1 and 5I1, which is going to be 6 plus 5. That's 11I1 minus 5I2 like this. All right, so you can just rearrange, start with 11 I1 minus 5I2, which is this side, is equal to 8. It's just one and the same thing. The left-hand side and the right-hand side, they are equal. And in this case, it's going to be difficult for us to divide this. You can see it's 11 and we do not have a common factor. So just leave your answer like this, which is fine. Then the loop 2, according to my diagram, according to the route that I've taken or the way that I've taken, this is my loop 2. Like I said, you can even choose to take it like this, the whole part of your circuit. It's up to you. So in this case, I'm just going to consider my loop 2 from the point B, C, and so on. So it's going to be B to C to D to the point E, then to the point B. It's fine like that, right? It's up to you the way that you're going to choose your loops in this case, or the loop to take in. All right, so from B to C to D to E, we consider B, C, D, E like this. It is the same current flowing, which is the current I2, and we are maintaining the direction of current. So that will be a positive, and we do not have a voltage source here in this loop. So we're going to have 0 is equal to 8 times the current of I2. Since we are maintaining the direction of the flow of current, that will be a positive. That is from B to C to D to E. We have moved up to E. So you're going to consider now from E going to B. So from E to B, this path here, as we are considering, take note, from our diagram, the current is going down. And as we are moving from E going up like this, so we are opposing the direction of current. So that is going to be a negative. So it's going to be negative 5 times the current affecting here, which is the current there, it's I3. But I3 is given as I1 minus I2. So that's it. Going to expand your brackets, collect your like terms, and so forth. You've got your equation there. So 8 minus, expand bracket, negative 5 times I1, which is negative 5I1, negative 5 times this, which is going to be a positive 5I2. So that's 0 is equal to negative 5I1. Add 8 and 5, which are the like terms for I2. So 8 plus 5, which is going to be 13. So that's 13I2. Here, to avoid this to be a negative, let us just transpose each and every term, also affecting the sign. So this will be a positive that side. So that's 5I1. If we take this, it will be a negative there. So it's going to be negative 13. I2 is equal to, if we take 0, 0 was supposed to be negative, but there's nothing like negative 0, guys. It's just a 0 there. So that is our final equation in this case. We've got two equations that we are going to consider. In this case, we have got this equation. All right, so that was our, let's just say, equation 1. And here we now have our equation 2. So remember, the question is to solve for the current that is flowing here, which is this I3. So the moment I calculate I2 and I also calculate I1, it means I can calculate I3, since we said I3 is going to be the difference between I1 and I2. So if I can find I1 and I2, I'm done. I have to determine this. So let us find I1 and I2 from the two equations that we calculated. We are going to formulate these equations further. All right, so let us have the first equation that was, so we now want to solve in this case. All right, so the first equation, it is given as 11I1 minus 5I2 is equal to 8. Second equation is given as 5I1 minus 13I2 is equal to 0, like that. All right, so these are the two equations that we are given. So we can solve for I1 and I2 in this case. All right, so as you can see, it's difficult for us to make either I1 or I2 the subject. So they're just going to work with your elimination. Depends with which part that you want to eliminate. Let's say I want to eliminate I1 in this case. It means I'm just going to simply oppose these two, multiply by 5 on top, multiply by 11 below. So the 5 is going to multiply each and every term on top. All right, so that means you're going to have 5 times 11, which is 55 I1. 5 times negative 5, which is negative 25 I2, is equal to 5 times 8, which is 40 there. The same thing with 11 is going to multiply each and every term that we have there. So it's 11 times 5, which is 55 I1 minus 11 times negative 18, that is going to be negative 143. I2 is equal to 0. 11 times 0, that's a 0 there. So meaning to say, we can eliminate I1 since we can see that we've got positive 55 and positive 55 there. So by subtracting equation 2 from equation 1, it means we can eliminate current I1 in this case. All right, so that's this one minus this one. It gives us a 0. So you're going to move on to the current 2, which is negative 25. So that's negative 25, negative. This negative that we see here, that's a minus. All right, but the number that we are subtracting is also carrying a negative. So that's minus 143 like this. And if you simplify properly on your calculator, this is going to give us a positive 118. So you're going to have positive 118 I2 is equal to 40 minus a 0 in this case, that's a 40. So to find I2, we can divide by 118 both sides. So that's, we've got I2 in this case. All right, so that'll be 40 over 118, or as a decimal, is going to be 0.33898, which is simply 9 in this case, amps. All right, 2 3 decimal places. That is going to be the current I2 in this case, but this is not the one that we want, as we are supposed to calculate I3, but we need I2 and also need I1. So you can find I1 by substituting into any of these two equations. And as for me, I'm just going to work with this one. It's easier since I have a 0 there, but you can choose whatever part that you want there. So just substitute your equation in your equation. So I'm just going to choose this one. That's 5 I1 minus 13 times I2, which is 0.339 in this case. All right, substitute in this place of I2. This must be equal to 0. All right, so that means 5 I1 is equal to, if I take this to the other side, it would be a positive 13 by 0.339. Or you can just multiply on your calculator direct, which is fine, or you can just divide it once by 5 this side. So that means our current one is going to be the product of this divided by 5, which is going to be 0.8814 and so on and so on. So that is 0.881 amps. All right, so this is our current one, not the current 3, the one that we asked. So the current, therefore, that is flowing across RL, which is across the 5 ohm resistor in this case, which is I3, is going to be given, like I said, I1 minus I2. So therefore, I1 and I3 in this case, therefore, we're going to have our I3, which is the current flowing through the 5 ohm resistor, as I1 minus I2, which is substitute I1, that's 0, I1, this one, 0,881 minus I2, which is 0,339. So you're going to have the difference between these two, which is 0,542 amps. So that is going to be the current I3 in this case, which is the one that we needed, which is the current flowing through the 5 ohm resistor. So that is the current flowing across or through flowing and the 5 ohm resistor. All right, so that's how these questions might be given as, and this might be an introduction that you're going to have for your industrial electronics N4, whereby you're given circuits of this nature, and you'll be given just to solve or use maybe Thevenin. We've got a lot of methods that you're going to use there on the same circuit that we are using the Kirchhoff's law. We talk of the superposition, the Thevenin, and so on. So you just need to know your basics, because it can also be under Kirchhoff's laws again. So, but you won't be given the direction of the loops. You are the one who is to create the loops for yourself. After creating the loops for yourself, you create your equations for yourself. Then from there, you can solve your equations to determine the exact current that you are given. So like I said, you can take these loops in a direction or in a way that you understand, but at the end, we must have the same answers as the ones that we are having here.